How engineers control cracks in concrete. Welcome back to Blueprint to Reality, where we turn complex civil engineering concepts into clear, practical knowledge. Today we're uncovering a problem every concrete structure faces: cracks. More importantly, we'll see how engineers don't just accept cracks. They control them. How engineers control cracks in concrete. 1. Why concrete cracks in the first place? Concrete is strong in compression but weak in tension. As it dries and hardens, it shrinks. When tensile stress exceeds its capacity, cracks form. Cracking is natural. The real challenge is controlling it so it doesn't become dangerous. Main causes of cracking. Shrinkage during curing temperature changes excessive loads, settlement of foundations. 2. Plastic shrinkage cracks. The early stage problem. These cracks appear when fresh concrete loses moisture too quickly before it gains strength. Hot weather, wind, and low humidity accelerate evaporation. Engineers prevent this by managing moisture from the very beginning. Prevention methods. Proper curing techniques, covering with wet burlap or plastic sheets. Using curing compounds, avoiding casting during extreme heat. 3. Thermal cracks. Temperature stress. Concrete expands when heated and contracts when cooled. If temperature changes are uneven, internal stresses develop and cracks form. In large structures like dams, temperature control is critical. The massive blocks of the Hoover Dam were poured in stages with cooling systems to prevent thermal cracking. Control strategies. Controlled pouring sequences, cooling pipes in mass concrete expansion joints. 4. Reinforcement, the crack controller. Steel reinforcement does not prevent cracks completely. Instead, it controls their width and distribution. By placing steel bars in tension zones, engineers ensure cracks remain small and harmless rather than wide and structural. Benefits of reinforcement. Limits crack width, increases ductility, improves durability. 5. Control joints, planned weak points. Sometimes the best way to control cracks is to decide where they happen. Control joints are intentionally created weak lines and slabs that guide cracks into straight, planned paths instead of random patterns. Common locations. Floor slabs, pavements, long walls. 6. Proper mix design. Strength from the start. The water-cement ratio greatly affects cracking. Too much water increases shrinkage and weakens the concrete. Engineers carefully design mix proportions to balance workability and strength. Key mix considerations. Low water-cement ratio, proper aggregate grading, use of admixtures. 7. Fiber reinforcement. Micro crack control. Fibers mixed into concrete help control microcracks before they become visible. These fibers distribute stresses more evenly and improve impact resistance. Types of fibers. Steel fibers, polypropylene fibers, glass fibers. 8. Foundation stability. Preventing structural cracks. Not all cracks start in the concrete itself. Uneven soil settlement can create structural cracks in beams, slabs, and walls. Proper soil investigation and foundation design prevent differential settlement. Structures like the Burj Khalifa rely on deep foundation systems to ensure uniform load transfer and minimize structural cracking. Prevention measures. Soil testing, proper footing design, uniform load distribution. Concrete cracking is not a failure. It is a behavior engineers understand and control. Through reinforcement, joints, curing, mix design, and proper foundation systems, cracks are managed long before they become a threat.